CSP is one of the most difficult methods in speedcubing to learn. This video will be by no means a full CSP tutorial, but I will introduce you to the resources you currently have at your disposal, as well as the process I recommend you learn it through. There are two parts to CSP. The first is to count how many parities are present for a scramble, and the second is to do an alg based on whether the number of parities is even or not. For every shape, you want to have a tracing order for the pieces. For example, for scallop, we can choose to start here and move counterclockwise. You generally want to choose a tracing order for each shape based on a consistent few rules, such as to always start tracing wherever the largest group of edges is. There are 6 parities you can get, but they're not that hard to trace for if you have unlimited inspection time. First, only look at the white edges, and using your tracing order, note down the non-white colors on the first 3 white edges. So we're going to start at this edge, go clockwise, so we see green, red, and blue. We will now take these 3 colors and reduce them to 2 non-opposite colors. Locate the pair of opposite colors in your 3 colors. If they're right next to each other, eliminate the second one of the 2. If they're not, eliminate the first one. Now, if you have blue-red or orange-green, you have a parity. Otherwise, you don't have a parity. So for example, these colors are green, red, and blue. Since the opposite colors are not adjacent, we will eliminate the first one of them. That gives us red and blue. That means we have a parity. You can do the same for black edges. For them, we have the colors, so we're starting from here going clockwise. Green, we're starting from here going clockwise, so green, blue, and orange. Since the opposite colors are adjacent, we will eliminate the second one of them. That gives us green and orange. That means we have a parity. To do this for corners, it's a bit more difficult. Each corner has 2 colors on it. To reduce the corners to 1 color, we will only look at the side that is most counterclockwise. That is to say, if we look at the shape like so, we will look at these sides. So for white corners, we have the colors, and we're starting from here clockwise, so it's going to be blue, green, and red. Since the opposite colors are adjacent, we will eliminate the second one of them. That gives us blue, red, which means we have a parity. And for the black corners, we have the colors red, orange, and blue, since we're starting from here, orange and blue. And since the opposite colors are adjacent, we will eliminate the second one of them. That gives us red and blue, which means we have a parity. Finally, look at every other edge. So the ones labeled 1 and 3 on the top and bottom. Count how many of these 4 edges are black. So on this scramble, this one is white, skip this one. This one is white, skip this one. This one is white, skip this one. This one is black, skip this one. So we have 1 black edge. If the number is odd, you have a parity. So in this case, we have a parity. Do the same for corners. So this one is white, skip this one. This one is white, skip this one. This one is black, skip this one. This one is black, skip this one. So we have 2 black corners, which means we don't have a parity. Finally, based on whether the number of parities we have is odd or even, we will either do an odd alg or an even alg. Most of learning CSP is dedicated to learning these odd and even algorithms. Odd doesn't necessarily mean bad, and even doesn't necessarily mean good. Since we have the odd case, we will just do normal scallop. If we had the even case, we would have to do a 3 swap beforehand, but we're just going to do scallop. To learn the odd and even algorithms for each case, the best tutorial online is Matt's YouTube tutorial. There are also plenty of written CSP documents that you can access using the CSP resources document that I'm putting in the description. I also recommend keeping a notebook to keep track and look up all your tracing patterns and your algorithms. The best trainer currently is the SquanMate trainer, and it's really the best resource to learn each CSP case. I recommend just starting slow, untimed, and carefully pointing to each piece of interest while tracing. Use your other hand to keep track of even and odd parity instead of mentally counting. So, what do CSP odd and even algs look like? A very common pattern is going to be the 3 swap. For example, the bad alg for mushroom square is going to be to turn it into pawn pawn, then do a 3 swap, before executing the rest of pawn pawn. Another common pattern will be the scallop L case that many other cases will reduce to. At this step, you have the ability to either form the kite in the front or in the back, and each one solves a different parity. You can apply this concept to cases such as fist scallop, scallop square, and some others. And even in other cases, the distinction between the even and odd algs will often be positioning things in the front versus the back. And finally, there are the cases that are just straight up different. For example, with this case, you have 2 completely different solutions with scallop scallop or shield shield. We can split the above into 2 categories of CSP cases. The ones where the even and odd algs are very different, and the ones where they are too similar. This is a very important concept to think about when dealing with mirrors. If you have this case, but flipped, you don't really have to worry about it much because it's still going to be shield shield if even or scallop scallop if odd, because those algs are very different. But with this case, you actually have to switch what you would usually do or conceptualize for this alg. If even originally meant to solve in the front, it would now mean to solve in the back. These cases are what I call swim cases, or switch with mirrors cases. Here are some tips to navigate them based on how you conceptualize cases like this. Some too similar cases are ones like this. The odd alg is to bring up this L, move down this L, and then you have scallop kite. Notice that this beginning of the alg is completely 2-gen. The even alg is to bring up this L, and then do a U D prime, move down this L, and then do scallop kite from the back. The way we conceptualize the difference between these 2 algs when memorizing the case is to use terms such as 2-gen or small move to describe one case, and 3-gen or big move to describe the other case. If you conceptualize it like this, then you will be able to extend the exact same logic to the mirror. For example, here, even still means the 2-gen or small move case, and odd still means the 3-gen or big move case. The second way is to use terms such as front or back. For example, we can think of the odd alg as solving it in the front, and the even alg as solving it in the back. If we do that, then this becomes a swim case. And if we trace odd, which means we originally have to solve the kite in the front, we have to solve the kite in the back for the mirror. Another example is this, scallop fist. The way I think about this is, if it's even, we put the L in the front. And if it's odd, we put the L in the back. Notice that this is front-back terminology, which means that this is a swim case. If I flip it, now even means we put the L in the back. And odd means we put the L in the front. Now this isn't a hard and fast rule, it's more of a general rule, and there are exceptions to it based on how you execute the algorithms, but I recommend just learning it just to aid with the initial CSP learning process. This is the way I conceptualize these cases, but it's a bit weird and unorthodox, so don't feel the need to do this if it just makes it more complicated. Another thing is to group asymmetrical cases, like pawns, fists, and 4-2. You rarely have to memorize an entirely different alg for left and right fist, or left and right pawn. Now it may be that the good alg for the left fist case is even, and the good alg for the right fist case is odd. If you get that, all you really have to memorize is left, even, good. From that, you can gain everything you need, because by switching any 2 words from their opposites, we get something else that's true, such as right, odd, good. If it's the case that odd is good and even is bad for both fists or both pawns, then all you have to memorize is odd bad for both fist cases. And so no matter what you have, you can just memorize one datum for both cases. An example of this is pawn square, where I just memorize odd good. So no matter which pawn this is, I know that odd means the good alg and even means the bad alg. Another example of this is 4-2 pair, where I memorized left, odd, good. I see that this is right 4-2, and I trace even. So I switch two of these words from their opposites and I get right, even, good. So I know that this is a good case. So just to summarize everything, we talked about the various CSP solutions you would see, we talked about swim cases, and we talked about asymmetrical shapes. Finally, just as a word of advice, CSP is difficult. It's going to take weeks to learn and months to put into practice, and it's also a skill you have to use regularly to not forget it. But once you've learned it, Square One becomes a breeze of an event, and it's just so much easier to improve on. It kind of becomes like 303, just a bit longer and with slightly worse hardware, and you can probably begin to podium at every competition you set foot in. Thanks for watching.